Okay, my friends, so as you are over here re-randomizing and collecting more data, so again, just to reiterate, every time I press F9, that's a new study. That's a new study. That's a new study. If only studies actually were that easy to do in the real world, right? Now, as we were re-randomizing, you may or may not have noticed this little box right here. Now let's zoom in on that and take a look. And you'll notice that it very often says, yes, did the sample catch the parameter? And I put catch in quotes. And the reason I put catch in quotes is because it's not really an officially statistical term, the idea of catching a parameter. So what does that yes mean right there? And what does it mean if it says no? See, there it says no. Very often it said yes. Let's go again. There it says yes. But every once in a while, there's another no. So what I want you to do is look in this formula with me. Now it's a little bit convoluted, but check out this formula. What it's doing is it's checking in this section right here, it's checking two inequalities. Is the cell in E4, that's the lower confidence limit, is it less than the value that's in L2? And at the same time, is the value in L2 less than the value that's in cell F4, which is the upper confidence limit? This is a fancy way of saying, is the value that's in L2 between the lower and upper confidence limits? Because that's what a confidence interval is trying to do, right? It's trying to catch the parameter between those two numbers. I just remembered like the best worst stat joke ever that actually explains confidence intervals pretty well. There's three statisticians and they're out in the woods bear hunting. They're hiding behind a tree and they see a bear go by. And the first statistician jumps up, takes a shot, and misses the bear 5 yards to the left. The next statistician jumps up, misses the bear 5 yards to the right. The third statistician jumps up, we got him! If you understand that joke, you understand confidence intervals. Sorry, back to the video. And this is the slightly fictitious part that's over here. Let's go over here and take a look at cell L2 and then make the font a color other than white. Aha! And what is that? If we chase that 1500.5, it's the average in the population sheet of columns M and V. And now you're seeing all my dirty secrets because back here, this is where I actually hid the entire population of values that you've been randomly sampling from, right there. So what you're seeing over here in this cell L2 is fiction. It's absolute fiction. You're never going to know it, which is why I hid it from you originally. But what I want you to think about now, and this is the last section of this question on the exam, is about how often are we seeing yeses versus nos? I'm looking for a percentage. What percentage of the time are we seeing yeses versus what percentage of the time are we seeing nos? Clearly, we're seeing a lot more yeses than nos, but I want you to put down an estimate of how often we're seeing yes versus no. If you get stuck with this, by all means, ask me for hints.